YouTube. In this video, we're going to continue our exploration of solving equations, but specifically what we refer to as rational equations. Now, in our last video, we actually looked at an example where we had fractions, okay? We solved an equation that had fractions. We said, well, first of all, it's not very desirable to have fractions, so what we'll do is we'll eliminate the fraction by multiplying both sides of the equation by the least common denominator, which immediately just goes and gets rid of the denominators, and we can just solve this as if there were not fractions. But the thing that sets this apart is you'll notice that all of our denominator values here were just simply numerical. In this instance, we say that these are rational equations because they're very like fractional equations, except for there are variable values in the denominator, okay? So what we want to do is solve these, and as a matter of fact, it says we'll solve these equations also by multiplying both sides by the LCD, but we say the difference does lie in the fact that some or all of the denominators contain variables. So what I want to kind of comment on here first before we start multiplying both sides by the LCD and solving, but is make this comment here. It is possible that there are x values for which our denominator is equal to 0. And the reason why they are of note is because if you were to put in 0 in for x in the denominator, say it here for 2 times x or 3 times x, you'll notice that you get 0 in the denominator, which is an undefined thing. So the first thing we're always going to do is this. One is find all values of x. I'm going to say x because we're using the variable x, but it could be the variable here for which the denom equals 0, okay? And then we're going to exclude these, okay? And then we'll multiply by the LCD. So I'll just go ahead and take you through a couple of examples of what this might look like. But you notice it says first list any x values for that must be excluded from the domain. So the way you do this is you basically set denoms equal to 0, solve for x. We're going to do this in each one, and then the next step will be multiply both sides of the equation of EQ by the LCD, and then we're going to solve. You know, this is just a kind of a basic thing you get used to after a while, but we have to start by listing all these x values. So any of these x values or denominator values over here containing x, if you were to set them equal to 0 and solve, I say, well, what if 2x was equal to 0 and I divide both sides of this by 2? Then I would say, well, then x equals 0. And then likewise here, you can see that easily, you know, if you plug in 0 here, you're going to get 0. So we say that first things first, in terms of like solution, maybe possibly solutions, we say x is not allowed to be 0 ever. I mean, it's the first thing we want to say. In this equation, x can't be 0, okay? But let's move on now and we say, okay, well, now multiply both sides of the equation by the LCD. Now recall, when you want to find an LCD for an expression or a set of denominators here, what you do is you factor the denominators completely. So I notice in my first denominator here, I have a 2 times x. I mean, you can't factor it more than that. 18. 18 is technically 6 times 3, which is 2 times 3 times 3. And then this one here is a 3 times x. So to find the LCD, what you always do, or at least what I tell people to do, is this. Just take all of the factors in the first denominator. Okay, I've got them, to the 2 and the x, okay? And then add to this list any that weren't already on the list from the other denominator. So, for instance here, I'm looking at this denominator. I already have a 2 in this list, okay? What I don't have is this 3 here. I don't have the 3 from this list here. So I'll cross off this 3 now that I do have it. I'll cross it off from both of these. 3 is on the list. I have to add in this other 3 here, okay? So add in that other 3, I've got to have that there. And I also already had this x on my list right here. So I can say, well, I don't need to add in another x, this is what I get here. So our LCD in this case is going to be 2 times 3, which is 6, times 3 is 18, and 18x is our LCD. That's what it is, okay? So we're going to take this equation here, and we're going to say, let's multiply both sides by 18x. So 18x times the left side of this equation, we get 5 over 2x. Is equal to 18x now times the entire right side, the entire stinking thing. We say 17/18 minus 1 over 3x. And so we'll just go ahead and now simplify both sides, but what I want people to see is this is really 18x over 1. And so when I multiply here, I get the x's that cancel. These are going to cancel out. And I say, well, 2 and 18 share a common factor of 2. So this will become a 1. It has to become a 1. And this will become a 9. So we get 9 times 5 on the left. So we get 45, and our denominators are gone on the left side. And we see on the right side, let's go ahead and distribute this through. I can easily see in this instance here that this 18 is going to cross off with this 18, and this is going to become just a 1x here. So if I took a 1x times 17, I would really get 17x in this spot. So now distributing the 18x over to here, I would see what we get is these x's cancel out, and then the 3 and the 18 share a common factor 3. So this has to become a 1 here. And we say that this 18 would become a 6. So now 6 times this 1 here we get, and I'm bringing down this negative here, this subtraction sign. We say minus 6 times 1 is 6. So man, this equation's really easy to go ahead and fire out. We'd say, okay, well if I did this, I'll add 6 to both sides, and I get 17x. And I would say adding 17 to this, I get 51. And if we divide both sides now by 17, we get some new equivalent equation, has the same solution set. And I get x is equal to, and this comes out to be a 3 here. Excuse me. So we would say the solution set for this equation on the left here is just simply 3. And I would encourage everybody to go back and plug this in and see that you get the same thing. So now, to look at another example here, this example is slightly different in that our factors in the denominators are actually binomial factors. Okay, so you have to actually quantify them. And so what we're going to do is this. Again, first we're going to list any values in a rational expression that allow our denominators to be 0. So if I set x minus 2 equal to 0 or x minus 2 equal to 0, notice I don't have to set 3 equal to 0 because it doesn't have an x in the expression. We'd say what would cause this to be 0 in the first place? I'd say, well, solving that equation I get this. So the first things first, when we talk about solutions for this equation here, solutions, we have to exclude 2 from the set of solutions. Like it can't be that, okay? I actually should write this over here, or maybe I should have taken these here and written it under the solution bar here. And I'll do that on this one, but we can't allow x to be 2. But that being said, let's go ahead and take our same tact that we had over here, which is multiply both sides of the equation by the least common denominator. So we say, what are the factors of the first denominator over here? We say, well, x minus 2 is its only factor, and this one has x minus 2 as its only factor, and this one has the 3 times 1. So I'm going to say, using my idea for finding the LCD, we'll list the factors of the first denominator on the very left here. We say x minus 2. We say, looking at the other denominators, okay, we will add in any factors that weren't already, on this list from the first denominator. So we have x minus 2. I notice this one already has an x minus 2, so I don't need to add that in. This one has a 3 though, so I need to add that into this expression. We say, well, this multiplier right here would be the LCD. And I'm going to say leave this, okay? Don't distribute, because what we're going to do here is we're going to take both sides of this equation times this value. So we're going to need a little room here. I'm going to borrow a little room here. We say, or either that or write smaller. We have x minus 2, and I'm going to put the 3 in front. 3 times x minus 2, we're going to take that times the entire left side of this equation. So we have x minus 2, and this is now end quantity here. And we say now we're going to take 3x minus 2. We're going to take that times the entire right side of the equation. I'm going to try to squeeze this in here. We had 2 over x minus 2, that factor there, and that was minus a 2/3. So now on the left side, when we distribute this, this is 3 times x minus 2 over 1. These x minus 2 factors cancel out, and we just get 3 times the x, and so we say 3x. And on the right side, if we distribute this through, we would say, well, this x minus 2 is going to cancel out with this x minus 2, leaving just the 3 times the 2, and we get 6 there. And now when I distribute it over to here, I would say, well, this 3 here is going to cancel out with this 3. And notice we get x minus 2 times this negative 2, or we say minus, and I'm going to write it this way, minus 2 times x minus 2. And that's important that we leave this x minus 2 as a quantity times this negative 2. So now to solve this equation, just as we do with the normal equation, we'll simplify both sides first. So we get 6, we get a negative 2x and a positive 4. We'll combine like terms here. So our constants, as far as the constants are concerned here, is we get a positive 6 and a positive 4 is a 10. So negative 2x plus 10. We'll go ahead and subtract 10 from both sides. Oops, hold on a second here. Don't need to do that. We need to get all our x's on one side. So it looks like negative 2x is the lesser of the two x values. So we'll go ahead and do the opposite of what we currently have, which is subtracting 2x. We'll add 2x to both sides. So I get 5x is equal to the constant 10, and now I'll divide both sides by 5 to get the x isolated. So we get x is 2, and so just like last time, I'm going to say, well, let's put that up here. And we say the solution set is 2. Now, how can that be if x is not allowed to be 2? So if x is 2, what we get algebraically, but we already noticed that x is not allowed to be 2, then what does this say about this solution set? Well, it means that 2 cannot be included. So really our solution set happens to be this one right here, which is the null set. So in other words, what we're going to write here is that this equation has no solutions whatsoever, and that is why it's important we check for x values for which we cannot plug those into the equations in the first place. Cheers.